Hey everyone, I'm Matt, a developer from Ohio. In this video, I'll be walking you through the Variance in Weather project. To complete this project, you'll need to be familiar with NumPy and statistics terms like mean, variance, and standard deviation. Let's get started. In this project, we'll use the Python library NumPy to analyze weather data. We'll use variance and standard deviation calculations to determine which month is likely to have the most favorable weather conditions. Before we add any code, let's make sure that we understand the 4 lines that are provided for us. On line 1, we use the import keyword to access a Codecademy specific library. This is some Python code written by one of our developers that allows us to view tables in the preview pane to the right. On line 2, we have another import statement. This one gives us the pandas library, which we need because our data is stored as a pandas data frame. Note that we import it as PD so that we don't have to write out the whole word every time. Line 3 is the same, but with the NumPy library. We'll use this library to calculate mean, variance, and standard deviation. Line 4 looks a bit different, but it's yet another import statement. This one imports the data itself. Remember that London data is a pandas data frame. To understand what London data looks like, we can view some of its entries. Data frames have a function called head that allows us to peek at the first 5 entries. Let's print that out. So we will use a print statement, and inside we will call londondata.head. If we save and run the program, we'll see this table appear down here on the console, and also more nicely over here in the preview pane. There are a lot of columns in this dataset. Which measurements might be useful when thinking about planning a trip? Give it some thought. We'll be back to this in a minute. For now, let's comment this line out. We might want to look at the head again later, but it's best to keep the console clear for other print statements. It might also be useful to know how many data points we have in this dataset. We can use Python's length function to get the number of entries, just like we would with a list or string. So we can print len for length, the length of London data. When we hit save, we'll see the total number of entries, just under 40,000. Again, let's keep the console clear by commenting this line out. If we want to see the number later, we can just uncomment this line again. Which column did you think would be the most helpful? In this project, we're going to look at the temperature C column, which gives us the temperature in Celsius. Instead of working with the whole data frame, we can grab the data series for temperature C. This will be more like a list of temperatures than a whole table. To get a series, we can pass temperature C to London data as we would a key in a dictionary. So, if we save temp, short for temperature, we can get all of the temperatures from London data by passing in temperature C. Now that we have this series of only temperatures, we can use NumPy to do some statistical analysis. We're going to get the average temperature, the temperature variance, and the standard deviation of the temperature C series. To get the average, we'll use NumPy's mean function. The mean of a dataset is the average you get by dividing the sum of the values by the number of values. Remember that we shorten NumPy to NP in the import statement. So our average temp will be equal to np.mean of all of the temps. We can use a print statement to see the average temp. So I will print average temp. And when we hit save, we'll see that number. This data is from 2015, so we now know that the average temperature in London in 2015 was about 12 degrees Celsius. We now know what average temperature to expect for the whole year, but how much might one day vary from the next? If the variance is low, then we can expect each day to be pretty close to 12 degrees. If the variance is high, then we can expect some days that are much colder or much hotter than 12 degrees. NumPy makes this calculation as easy as the average. We just need to use np.var. So our temperature variance is going to be np.var, and we'll pass in temp. We'll print this number as well. So I will print temperature var. When we save, we'll see this number. The variance is about 30, but that's not 30 degrees. The true deviation in degrees Celsius that we can expect is going to be the square root of this number, otherwise known as the standard deviation. Standard because it's normalized to our original unit of measurement. We know that the standard deviation is the square root of the variance, but just like with the variance calculation, NumPy gives us a shortcut. We'll use np.std. So our temperature standard deviation is going to be equal to np.std, again passing in temp. Again, let's print this out. So I will print temperature standard deviation and hit save. We can see that our standard deviation is about 5.5. This time that actually is degrees Celsius. So how do these values help us? The average and the standard deviation give us a range of expected temperatures. 12 minus 5.5 is 6.5. 12 plus 5.5 is 17.5. So we can expect temperatures between 6.5 and 17.5 degrees Celsius. The variance isn't actually too helpful in this situation. You won't typically need to analyze both variance and standard deviation, because they're both advantageous in different situations. Variance is great for mathematical analysis of several datasets, especially when looking at the variance between datasets. Standard deviation is better for human eyes, because it's in the original unit of measurement, so it's easier for us to understand. So, we don't need variance in this situation, but it's important to understand how these three values relate, so that you can decide which to use for any given project. We know the average and standard deviation for a whole year in London, but that won't be very helpful when trying to plan a trip. We would get more apt information by comparing the averages and standard deviations from every month. That is, we can run the same analysis 12 times to see which month is the most appealing. We can filter this data, but we'll need to find a column that shows which month the given temperature was recorded in. Scrolling through the table, we can see a month column, all the way at the end. If we filter by this, we'll be able to get 12 separate averages and standard deviations. Don't worry if you're not familiar with filtering a pandas data frame. The instruction for task 8 gives us the code to copy and paste. The code we just pasted gives us a series, just like we did in task 3. Notice how we access temperature C in the same way, square brackets after London data. The difference this time is what's in between, the LOC object, which is a location-based indexer. All that means is that by using it, we get a subset of the London data frame based on a condition. Our condition is that month is equal to 6, so our subset only contains data with 6 in the month column. Because we access the temperature C series after the LOC object, we're only accessing temperatures from that subset. Again, don't get too caught up on the complexities of pandas for this lesson. All you need to know is that June is a series just like temp from above, except that it only contains data from a single month instead of from the whole year. To compare one month with another, we can copy and paste this same line and change 6 to another number. For example, July is month 7. So we'll paste in the same line, but this month equals we can change to 7, so that we are filtering for July instead. We can print the averages for both of these months, just like we did for the whole year, with np.mean. So we can print np.mean of June, and we can print np.mean of July. Remember that averages aren't the whole story. June is likely to be cooler than July, but we don't know the range of possible temperatures until we look at the standard deviation. We can print these values in the same manner as the averages. So that'll be print np.std of June, and print np.std of July. We can tell that, based on the 2015 data, June is likely to be colder and more varied, but just by a little bit. Now, we could write this out 10 more times to get the result for every month, but fortunately, Task 12's instruction gives us a block of code that does this for us. So I'll paste that in, and hit save. Take a look over the results and see which month seems the most appealing to you. For my money, I'd probably go in August, which would average 18 degrees and vary between 15 and 21 degrees. That's about 60 to 70 degrees Fahrenheit if you come from a country that uses imperial measurements like mine. Task 13 gives us a couple of ideas for expanding on this project. The first is to look at data other than just temperature. London has a reputation for gloomy weather, so rainfall could be just as informative as temperature when planning a trip. The switch from temperature to rainfall is easy once we find the correct column to use. We can exchange temperature C for daily rain mm, which gives the rainfall in millimeters. So in this for loop, we should change out temperature C for daily rain mm. We should also switch out the word temperature where it appears in the print statements. Once we've selected a month to visit London, we might plan a more precise itinerary. For example, we could plan to see the London Eye. It would be good to know what time of day to visit, as rain might ruin the view. Instead of filtering by month, we can filter by hour. The calculations will work out in the same way, except that we'll end up with averages and standard deviations for each hour of the day. We'll need to replace month with hour in a few places, including the print statements. One last consideration is to increase the number of results from 12 to 24, as there are twice as many hours in the day as there are months in the year. The first line of our for statement determines how many months or hours to check. It currently goes from 1 to 13, because the first argument is inclusive and the second argument is exclusive. That is, it will not continue if it reaches 13, so 12 is the last month it'll work on. If we want to go up to 24, we will need to consider this rule for the upper bound of a range. You might think that we should input 25, but hours, unlike months, do actually start at 0 in this data frame. Our highest numbered hour is 23, so our range should go from 0 to 24. In this project, we used NumPy to analyze a pandas data frame. We singled out a data series from the larger set and filtered by specific criteria like month or hour. We discussed the differences between variance and standard deviation, then used np.mean and np.std to get the average and range for each subset of data, which allowed us to make informed decisions. I'm Matt for Codecademy. Happy coding!